this, we're trying to find the sine of alpha and the sine of beta. But does 5 pi over 3 or square root of 3 recognize as, well, square root of 3, you could possibly say. But as 5 pi over 12, we don't have anything to like 5 over 13. We don't have any point on the unit circle that we've completed, right? Is anybody aware of what that angle is on the unit circle? No. So therefore, since it's not obvious that we can use the unit circle as like a shortcut, we're going to want to have to create a triangle. Now, we can't just create any triangle. They're giving us constraints of our angles. So the first constraint says the angle alpha has to be between pi halves and pi. So I'm going to create a quadrant system and say, all right, pi halves and pi then has to be an angle within what quadrant? Second. Notice how I drew my triangle. Okay, so we're going to use the reference angle as my angle, because that's technically my angle right there. Or my angle is in between those two. But we're going to use a reference angle. Just note how I created that angle. And we have sine, which is 5 over 13. Then the next one, we have between 0 and pi halves, which is going to be an angle in which quadrant? 0 and pi halves. So it'd be in the first. OK? So does everybody see what I did? I created two triangles. Now, we know sine is opposite over hypotenuse. That's not as bad. Tangent is opposite over adjacent. But the problem is we don't have a fraction here, do we? So let's just create one. You can always put it over 1. OK? So now, I'm sorry, I didn't even write down what the problem was. The problem is going to be cosine of alpha plus beta. Let's do sine of alpha, sorry. Let's do sine of alpha minus beta. OK? So by using our formula on our formula sheet, we know we're going to need to have sine of alpha cosine of beta minus cosine of alpha times the sine of beta. Whatever, good. That's just the formula per the formula sheet. Instead of using u and v, I'm using alpha and beta. OK? So all I did was just replace my variables. But since we have these two triangles, can we find the sines and cosines of them? Yes, absolutely. What is the sine of alpha? Well, alpha's over here. That's 5 over 13. That was easy. What's the cosine of beta? Oops, we need to have the hypotenuse. So we need to use the Pythagorean theorem. So 1 squared plus square root of 3 squared equals r squared, which we call the hypotenuse. So we have 1 plus 3 equals r squared. 4 equals r squared. That equals 2. So cosine is going to equal 1/2 minus cosine of alpha. Uh-oh, I need to figure out alpha here, or the adjacent side, right? But please remember, guys, or you could use Pythagorean theorem again. Or if you remember from your geometry class, that's actually a Pythagorean triple. So if you did Pythagorean theorem as well, you get 12. But again, which quadrant am I in?
You're in the second.
So going to the left, 12 should be what? Negative. So therefore, cosine is negative 12 over 13. And then sine is 5 over 13. Or sine of beta, I'm sorry. That's square root of 3 over 2. So now, instead of using the unit circle to evaluate, we're using the triangles that we created to evaluate. Do you guys see the difference in this problem and the other one? OK, no. Now, you just do the math and simplify. 5 over 26. Negative times negative is a positive. Denominators are the same. Combine the numerators.